Our today's lesson is about reflection. Consider this figure here. The first figure is a triangle ABC, which is reflected about the line, and the image is formed triangle A prime B prime C prime. Here, the difference is that only opposite in base, but they have equal distance from each point. That means if take vertex A is equal distance with vertex A prime from the line. So, this case reflection on the line L, if we take a point A, and its images formed with equal distance A prime, that is map at A. Here, A and A prime has equal distance from the line. So, depending on this, a reflection has those three properties. There are three properties of a reflection. The first property is, as a reflection takes a point with equal shape, equal distance. Sometimes maybe the difference is that opposing face. If you take this triangle above, the difference is that opposing face. So a reflection about a line L, for 2 point A and B, that means if A and B are different points that reflected on the line, then if A is equal with B, that satisfies the property of reflection for 2 point A and B, that if A is equal with B, then map at A is also equal with map at B. This means image of A and B are equal, as A and B are equal. Hence, in reflection, we say that a reflection is a function mapping because it maps equal distance with equal locations. This is one of the basic properties of reflection. The second property of reflection is that if you take a distinct point on a line, that is, or if you take to map a point on a line, a reflection maps distinct point to distinct point. That is, if A is different from B, that means if point A is different from point B, then the map is also different. Map at A and map at B is also different. That is, map at A is different from map at B, or image at A is different from image at B. If map at A is, or image of A is equal with image of B, then A is equal with B. This second property shows that the reflection is a one-to-one mapping, as it is a function mapping. Also, in this case, a reflection is a one-to-one mapping. And the third property is for a point A prime, in the plane, there exists a point A such that map at A is equal A prime, to A prime, that is, the image is equal. If a point A prime is on L, then there exists A is equal to A prime. A is equals to A prime. A is equal with A prime such that or implies that map at A means map of or image of A. Thus, in the third property, we say that reflection is said to be onto mapping. So there are three properties of reflection. Reflection, that is onto, one-to-one, and it is function mapping. Now let's consider a relation or about a line L, that is y is equal to mx and y is equal to mx plus b. Let's see the first one. A reflection about a line y is equal to mx. A reflection on the line passing through the origin and that make an angle theta from positive x-axis to the line that passes through the origin. That is, a line at least passes through the origin, then we make an angle from positive x-axis clockwise to the line on the plane, from positive x-axis to positive axis that passes the line on the origin. In this case, theta is equals to 0. And this line is a line L, and an angle theta is mapped from positive x-axis to the line, then that is the angle. So depending on this, the value of theta, we have the following special cases that based on theta. There are four special cases depend on the value of theta. The first property is when theta is equals to 0. In this case, we have reflection in positive x-axis because a line is on positive x-axis, so theta is 0. Theta is 0 means cos theta is 1, sin theta is 0. So we have a reflection on positive x-axis. So the image of the point xy is mapped to x comma minus y because we have a reflection on positive x-axis as theta is equals to 0. So the image is always mapped to x comma minus y for the given point x comma y. If you take example, let's take the point. Find the image of the point 2, 3. This point is on positive on the first quadrant, that is p comma p. Point p at 2, 3 means for x is 2, y is 3. This image is on positive x-axis. The line is positive axis, theta is 0. Therefore, the image of this one is mapped to 2 comma minus 3. P prime became in the fourth quadrant, that is p prime 2 comma minus 3. The y became negative. So we have for the given point p to 3, its image p prime is mapped at fourth quadrant 2 comma minus 3 from the figure. Therefore, we conclude that p prime is 2 comma minus 3. Let's see a second special case. Second special case is when theta is prior to for theta is pi over 2. That means at 19 degree. In this case, theta is 19 degree. So the reflection or the image became on positive y-axis. Positive y-axis. So if you take a point xy, its image is mapped to minus x comma y, because theta is pi over 2, cos of pi over 2 is 0, sin pi over 2 is 1. Therefore the image became on the second quadrant, that is for the point xy became minus x comma y. Let's see example for this one. Example, find reflection of the point 2, 3 over the line y-axis. Let's see on the image on the plane. Now the point P is given, that is 2, 3. 2, 3 is P. So the image of P is mapped to second quadrant, that is minus 2, 3. Minus 2, 3. Therefore we conclude here the image or P prime became minus 2, 3, because theta is pi over 2. Then the image is on second quadrant. The third special case is for theta is pi over 4. Theta is pi over 4 means 45 degree that pass through the line y is equals to x. So that is hence the image of any point xy in this line mapped to y, x, simply interchanging x and y. The image is obtained by interchanging x and y. The first entry x became second entry became the first entry. So hence the reflection of a point xy became or mapped to a point yx. Let's take example for this one. Take examples. Let's take the point minus 3, 2 to find the image of minus 3, 2 on the line or over the line y is equals to x. Satisfy the property that we have seen for theta is pi over 2. The image of a point xy became yx. So in this case, the image of minus 3, 2 is 2, minus 3. That is obtained by interchanging x and y. Let's see on plane this one. Put the point first minus 3, 2 on the plane, on coordinate plane minus 3, 2, that is point P. Then the image is mapped to 2, minus 3 in the fourth quadrant, from second to the first quadrant. That is mapped to P prime at 2, minus 3. Now we conclude this one as, therefore P prime, that is image of P, minus 3, 2 became minus 3, 2. The last special case is for theta is 3 pi over 4. For theta is 3 pi over 4. Here we have a relation about the line y is equals to minus x. The line y is equals to minus x. So the reflection of this point, a point x, y is mapped to minus y, minus x, interchanging x and y, then multiply by minus. So for any point xy, the image became minus y, minus x, minus y, minus x.